Welcome back to the deep dive. Today we are looking at a topic that kind of sits right at the intersection of computer science, geopolitics, and, open source philosophy.
Yeah, it really is a fascinating intersection.
We are examining the current landscape of large language models, but we aren't talking about the usual suspects out in Silicon Valley. We are looking at what happens when the broader scientific community decides to, well, essentially build a direct competitor to big tech.
And do it completely out in the open.
Exactly. So today's deep dive is based on a massive paper titled BLOOMZ, a 176B parameter open access multilingual language model, along with its technical documentation.
Right, so to set the stage here, we all know large language models are incredibly powerful. I mean, you use them, I use them, they write code, they draft emails, they summarize documents. But there is a huge catch with the models we typically rely on.
The ones from the major resource-rich organizations.
Exactly, they're basically black boxes.
Right, because these models are wildly expensive to train, and they're proprietary. They're kept strictly behind closed doors.
And that opacity, it's a feature for the companies building them, not a bug. But if you are a researcher trying to figure out why a model hallucinates or why it exhibits a certain bias, you just hit a brick wall.
Because you can't see the training data.
You can't see the data, you can't inspect the underlying weights, you are forced to study a commercial product from the outside looking in.
Which completely locks out the broader global research community. And as a byproduct, it leads to models that are primarily trained on English text, which ignores a massive portion of the world.
Which brings us to the solution, or at least a massive step toward a solution. BLOOMZ.
Right. So BLOOMZ, the acronym stands for Big Science, Large, Open Science, Open Access, Multilingual Language Model. It's a bit of a mouthful.
It is, but the mission behind it is incredible. It's about democratizing powerful AI. And the headline number here is 176 billion parameters.
And that 176 billion, that's not just a random number they landed on, right?
No, not at all. That specifically puts BLOOMZ in the exact same weight class as major industrial models like GPT-3. The goal was to prove that you don't need to be a massive tech corporation to build a state-of-the-art model.
And later in this deep dive, we're going to get into how 1,200 researchers from 38 countries pulled this off. Plus, how they trained this massive model using nuclear power to save on carbon emissions, and why it speaks 46 languages, including Basque and Shoshone.
It really is a massive collaborative achievement.
So let's talk about that collaboration, because usually when a massive model drops, it comes from, one shiny campus in California. But the Big Science Initiative was completely different.
Oh, completely. It wasn't a corporate project at all. It was a global consortium. We are talking about over 1,200 registered participants.
Which sounds like an absolute logistical nightmare.
I mean, the coordination alone must have been staggering. But you have to think of it less like a Silicon Valley startup and more like CERN.
Like the particle physics lab.
Exactly. It's a massive piece of public scientific infrastructure being built by a global community.
And who paid for the compute? Because 176 billion parameters isn't cheap to train.
Right. So the compute was provided by a French public grant through an agency called GNCI, and they used the Jean Zay supercomputer near Paris.
Okay, so public funding, public supercomputer. And the core philosophy here was fundamentally different from the status quo.
Very different. The project prioritized inclusivity, diversity, openness, and crucially, reproducibility. They were pushing back against an industry norm that prioritizes internal performance metrics over societal impact.
Shifting the power dynamic from a few closed-off boardrooms to a global scientific community.
Precisely. And that shift is most obvious when you look at how they handled their data.
Yes, let's get into the data.
Yeah.
Because this is fascinating. We are talking about the roots corpus.
Right. To understand why the roots corpus is such a big deal, you have to understand the data problem in standard LLMs. Usually, companies want data fast and cheap, so they do a massive web dump.
Just scraping the whole internet.
Exactly, using things like Common Crawl. But the internet is full of garbage.
Let's put it mildly.
Right. So to clean it up cheaply, they use heuristics-based filtering. Basically, automated block lists that hunt for specific keywords and just delete the text.
But those block lists have massive blind spots.
They do. The BLOOMZ paper highlights a really damning example of this. In previous models, these automated block lists were trying to filter out pornographic content. But in the process, they accidentally filtered out massive amounts of text from LGBTQ+ communities.
Wow.
Yeah, and also text written in African American English. It was just flagged as low quality or explicit and deleted.
So by trying to automatically clean the data, They essentially silenced entire communities.
Yeah.
They biased the model before the training even really began.
Exactly. So the big science team took a totally different approach with BLOOMZ. They introduced the roots corpus, which is 1.61 terabytes of text. And their guiding principle was humans for humans,
Meaning what, exactly?
meaning they prioritized human selection of sources over blind automated scraping. They wanted text written by humans for humans.
And this is where that massive team of 1,200 researchers comes into play, right?
Yes. They actually organized hackathons around the world to build the big science catalog. They had people identifying local data sources like regional newspapers or academic archives in their native languages.
And the multilinguality of this model is really impressive. It's 46 natural languages and 13 programming languages, so 59 in total.
Right, and while Indo-European and Sino-Tibetan language families still make up a large chunk, they made a massive effort to include Niger-Congo languages.
Like Yoruba and Swahili.
Yes, and Indic languages like Hindi and Urdu. They required at least 21 specific human-curated sources per language category.
That is a huge step up from just hoping a web crawler randomly picks up some Swahili.
Yeah.
But what about privacy? If they are pulling all this text, including some web crawl data, aren't they pulling people's personal info?
They were very careful there. For the web crawl portion of their data, which they called OSCAR, they used regex-based redaction.
Regex meaning regular expressions, just code that looks for specific patterns.
Exactly. They used it to scrub out personally identifiable information, things like social security numbers, phone numbers, that kind of thing. They really tried to respect the data.
Okay, so they have this incredibly diverse, carefully curated, massive data set.
Mm-hmm.
Now they actually have to build the thing. Let's talk about the engineering and specifically the green compute aspect.
This is one of the most surprising takeaways from the paper.
Yeah, so let's set the scale first. They trained this on 384 NVIDIA A100 GPUs, and these were the 80 gigabyte versions, which were incredibly powerful.
Top of the line. And they ran them continuously for 3.5 months.
Which sounds like an environmental disaster waiting to happen. Training runs of that size consume massive amounts of electricity.
They do. But here's the aha moment from the paper. They track their carbon footprint very closely. Training BLOOMZ generated approximately 25 tons of CO2 equivalent.
Which, out of context, sounds like a lot.
It's about the same as a few dozen people taking a transatlantic flight. But you have to look at the industry baseline. Training GPT-3 generated roughly 500 tons of CO2.
500 tons.
Yes. And a model called Gopher generated about 350 tons.
Wait, so it's 25 tons for BLOOMZ versus 500 tons for a comparable model. How is that massive a reduction even possible?
It all comes down to the power grid. Remember, they used the Jean Zay supercomputer in France. The French national energy grid is heavily reliant on nuclear power.
Ah, so the energy itself is low carbon.
Exactly. It has a drastically lower carbon intensity than the grids powering data centers in many parts of the U.S. It proves that where you choose to train your model is just as important as how efficiently you code it.
That is a brilliant takeaway. If you want to make AI greener, move the compute to a greener grid. But speaking of the compute, the technical documentation makes it sound like the training process itself was incredibly stressful.
Oh, it was a massive engineering hurdle. When you are running nearly 400 GPUs at maximum capacity, things break. They were experiencing 1 to 2 hardware failures every single week during training.
So a GPU just dies, and what, the whole massive brain pauses?
Pretty much. You have to have incredibly robust checkpointing to save your state, swap the hardware, and restart without losing months of progress.
And they also had software instability issues, right?
Yeah, numerical instability. This is a common issue with decoder-only transformers of this size. The math deep inside the neural network gets too large or too small for the standard data formats to handle.
Like an overflow error on a calculator.
Right. So to solve it, they used a format called bfloat16. It sacrifices a little bit of precision to handle a much wider range of numbers, and they mixed that with full precision for the really sensitive operations. It finally stabilized the training.
They also mentioned using something called ALiBi for positional embeddings. What is that?
ALiBi was crucial. Normally, a language model struggles if you ask it to process a sequence of text that is longer than what it saw during training. ALiBi is a different way of injecting positional information into the model so it can extrapolate better.
It helps the model understand the order of words, even in super long documents.
Exactly. It made the training much more stable and improved overall performance.
Okay, so they conquered the hardware dying, they fixed the math, they trained it on a nuclear grid. The ultimate question is, after all this open source, community-driven effort, is BLOOMZ actually any good?
The short answer is yes. It achieves highly competitive performance.
Competitive with the big corporate models.
Yes! When they evaluated it on standard benchmarks like SuperGLUE, which tests things like reading comprehension and logic, Bloom performs comparably to models like OPT-175B and GPT-3.
That is a huge win for the open source community. What about translation? Since it was trained on 46 languages, it must be incredible at it.
It is very strong in certain areas, but there are nuances. It is fantastic at translating between high-resource languages like English to French, and it's also very good at translating from high-resource to mid-resource languages like English to Vietnamese.
Makes sense?
It also excels with Romance languages. Translating between Spanish, Portuguese, and Galician works beautifully because the languages are structurally related and there's plenty of data.
But what about those low-resource languages we talked about earlier? You know, the ones they specifically held hackathons to find data for.
This is where the model struggled. The translation performance between underrepresented low-resource pairs was weak. Specifically, they noted that translation between Swahili and Yoruba was poor.
That's a bit disappointing considering the effort they put in.
It is, but it's an important scientific finding. It proves that simply including a language isn't magic. If the absolute volume of high-quality data in the world for those language pairs is too low, the model just can't learn the deep connections.
It really highlights the need to generate and preserve more digital text in those languages.
Exactly.
Let's talk about coding. Can I use BLOOMZ to write software?
You can. It was trained on 13 programming languages. On a coding benchmark called Human Eval, its performance is similar to GPT models that were trained on similar general datasets.
But how does it compare to a model built specifically for coding?
It lags behind specialized models like Codex. BLOOMZ is a generalist. It can code, but it's not a dedicated programmer.
Got it. Now, I want to bring up something called BLOOMZ, with a Z at the end. The authors mention this as a post-training step. What do they do there?
Yes. After the main training was done, they applied something called multitask prompted fine-tuning to create BLOOMZ.
Multitask prompted fine-tuning. What does that actually mean for the user?
Basically, they took the finished model and trained it further on a massive variety of tasks, but specifically formatted as instructions. They taught it how to follow directions across different languages.
And did it work?
It resulted in a massive boost in zero-shot performance, meaning if you give BLOOMZ a completely new task it hasn't seen before, it is much better at figuring out what you want and generalizing to that new instruction than the base model.
That is awesome. Okay, let's pivot to the ethical evaluation. Earlier, we talked about how they avoided the automated block list to prevent bias against LGBTQ and African-American English communities. Did that actually result in a fundamentally less biased model?
They evaluated this using a dataset called Crow-S pairs.
How does that work?
It presents the model with two sentences. One contains a stereotype about race, gender, religion, etc., and the other is a neutral statement. The goal is to see if the model has a systematic preference for the stereotyped sentence.
And if it's completely unbiased, it should just guess randomly, right? Like a coin flip.
Exactly. It should hit about 50%.
And what did BLOOMZ score?
BLOOMZ's accuracy on these prompts was very close to 50%.
Wow, so it is unbiased.
Well, we have to be very careful here. The researchers put a big caveat on this. Scoring 50% on this specific multiple choice metric suggests an absence of systematic preference in this narrow test, but it does not mean the model is completely bias-free.
Right, because bias can be incredibly subtle. It might not show up in a simple A or B test, but it might manifest in a long-form generated story.
Precisely. Bias is deeply complex, and no single metric can declare a model safe.
They also noted some quirks with how the model generates text, right? Something called overgeneration.
Yes. In translation tasks, especially in zero-shot settings where you just give it a prompt with no examples, the model would sometimes overgenerate. It would get stuck repeating the same text over and over.
Or I read it would sometimes just answer in the completely wrong language.
Right. Because it speaks 46 languages, it occasionally gets confused about which one it's supposed to be using. However, they found that providing just a single example in the prompt, a technique called one-shotting, usually fixed that issue entirely.
Okay, so we have this powerful, transparent, multilingual model. Now we need to talk about how people actually get their hands on it, the licensing. Because they didn't just throw this out on the internet with no rules.
No, they didn't. And this is a crucial innovation of the Big Science Project. BLOOMZ is released under a Responsible AI license, or RAIL.
A Rail license. How is that different from standard open source? Like, if I write some code, I usually just slap an Apache 2.0 license on it and call it a day.
And interestingly, they did use Apache 2.0 for the source code of the training framework. But for the model parameters themselves, the actual brain of Bloom, they used the Rail license.
Why the distinction?
Standard open source essentially says, here is the code, do whatever you want with it, just don't sue us. It's incredibly permissive. But an LLM isn't just code, it's a powerful system that can be misused.
So the Rail license puts behavioral restrictions on the user.
Exactly. It allows completely free use and access, but it includes 13 specific behavioral restrictions.
Give me some examples. What can I do with Bloom?
You cannot use it to generate medical advice. You cannot use it for law enforcement profiling or biometric identification or to generate deepfakes for disinformation.
So it's open, but it has legal guardrails to prevent harmful dual use.
Right. It empowers developers to build with it freely, but it gives the creators a legal mechanism to revoke access if a bad actor is using the tool to cause societal harm. It's a really elegant attempt to balance open science with AI safety.
So taking a step back, looking at this whole massive undertaking, 1,200 researchers, nuclear-powered supercomputers, 46 languages, novel licensing. What is the ultimate legacy of Bloom?
I think its legacy is that it serves as a massive proof of concept. It proved that large-scale, state-of-the-art AI does not have to be built inside a corporate walled garden.
It completely shatters the narrative that only a trillion-dollar tech giant has the resources to play in this space.
Exactly. It shows that a global community can collaborate, build something world-class, and do it transparently and ethically.
So if you are listening to this, I want to leave you with a final provocative thought based on what we've unpacked today. We've just seen proof that a community of researchers can build a massive state-of-the-art model that respects data privacy, slashes carbon emissions, and opens its architecture to the world.
It really raises the bar.
It does. So why are we, as a society, still so willing to accept the black box status quo from big tech companies? If the open scientific community can show us their data and their carbon footprint, why can't the industry giants?
It's a question of accountability.
And further, what happens to the future of the internet and digital knowledge itself if we rely entirely on proprietary models that only truly understand English and the Western world?
That is the defining challenge for the next era of AI development.
It truly is. If you want to explore this further, I highly encourage you to look up the Big Science organization. You could even try out the Bloom model yourself right now on Hugging Face, since it is completely open access. Thanks for joining us on this deep dive. We will catch you next time.